In this section, we'll use GATK haplotype caller to call germline SNP and indels. First of all, please make sure you are in the correct directory. Your directory should be should have your username in between the project directory and the DNA-seq directory. And we are in the GATK workshop 2 germline folder. And then, after making sure you are in the correct directory, please copy and paste the command from my tutorial. We are using haplotype caller to use the reference in the ref folder and use the mother BAM file in BAM's folder, and specify the output, save the output file mother.hc.vcf to the sandbox folder, and specify the genomic location is in chromosome 20 and in this particular genomic positions that we are interested in. Now we can run the haplotype caller. Now we can open our IGV and start a new section, and make sure our genome reference is B37 with decoy genome, and load both BAM file and the VCF file. Mother BAM. And the VCF is in the sandbox. Zoom into chromosome 20. And we have a specific coordinate. The interval 10 million, 002, 294 to 10 million, 002, 623. Let's go to that interval. If we zoom out, we can see there are some homozygous variants and also some heterozygous one. So here we can see that the haplotype caller called a homozygous variant insertion of 3 base pair. But looking at the reads, how many reads has the insertion? Not many. I think there are about 30 reads here, but only 3 of the reads show the insertion. So how is it possible that when so many reads seem to support an insertion at this position, but the haplotype caller called this as a variance? So when we encounter the indel-related weirdness, we need to turn on the display of the soft clips. By default, IGV turn it off. Let's go to File. Let's go to View, Preference, Alignment, and select Show Soft Clipped Bases. Here. Okay. Now you can see there are so many areas that just light up like a Christmas tree. Those are soft clipped bases by the BWA-MEM software, the alignment software. So the BWA-MEM think that those bases, the penalty to assign them as a soft clip is better than the penalty to assign the insertion. So haplotype caller has a parameter called BAM out, allow us to ask for the realigned reads. These realigned reads are what haplotype caller use to make its variant calls. So you will be able to see if a realignment fix this messy region. Now let's ask the haplotype caller to output this BAM out, this mother HC debug BAM to see the realignment has done by haplotype color. Okay, it's done. Now let's open IGV again. Load the debug BAM. Now it's clear that there are many reads show the insertion. Either it's a 3-base insertion or 2-base insertion. And all those colorful, soft-clipped reads are gone. And this area looks much better than the first alignment. The haplotype color calls both SNP and indel simultaneously via local de novo assembly of haplotypes in an active region. Essentially, when this variant color finds a region with signs of variation, it toasts out the old alignment information from, for example, BWA-MEM, and performs a local realignment of reads in that particular region. This makes haplotype color more accurate in regions that are traditionally difficult to call. For example, the regions with soft clip, like this case, or the region contain different types of variants close together. In those complicated regions, position-based colors like a unified genotyper simply cannot compete. Here, let's look at the variant called by haplotype color, this insertion variant. I just click on the variant in the VCF track. The reference is a G only and the alternate is a GTTT, so it's a 3-base T insertion. Well, let's look at our reads. We see there are some reads with 3 insertion, but also 3 bases insertion, but also there are many reads with 2 bases insertion. Why haplotype color choose to call the 3-base insertion instead of 2-base insertion? Let's zoom out a little bit. Okay, we can first color the alignments by the read group, and then group the alignments by the read group. Okay, now there are 2 read groups separated. On the top is artificial haplotype read group. These 3 reads are not real. They present artificial haplotypes that were constructed by haplotype color and are tagged with a special read group identifier. Let me just click one of them. The read group is artificial haplotype RG, and it assigns it a HC. It's like a likelihood calculation, how likely this haplotype is supported by the reads. And I was clicking on the haplotype without any variants, same as reference, and the HC score is negative. If I click the first one, the one with 3-base insertion, the HC tag, let's look at what it shows. The HC tag score is 1,400,000,000. And let's look at the haplotype with 2 base insertion. The HC score is 700 million. It's about half of the HC tag in the 3 base insertion. So that means the reads supported the 2 bases insertion is less than the reads support to support the 3 base insertion. And there is another way to see it clearly by color the reads by the tag, HC tag. Color alignments by tag. And in the pop-up window, we just type in the HC tag. Okay, now we can see the top 3 artificial haplotype reads are colored differently. The pink one corresponding to the 3 bases insertion. There are 6 reads support this haplotype. And the purple one, there's no read support the reference. And the green one is the 2 base insertion. There are only 2 reads support this 2 base insertion. So the haplotype caller decide to call this variant as a 3 base insertion.